Well, thanks everyone for being here for energy codes training. We've got today on Crawlspaces, and then on the 31st, fireplaces and tight homes. And then we'll be kind of continuing summer, fall, various topics, the mechanical code, lighting code as applied to commercial structures as well. And then Jerry will be back for more lectures as well. Residential and just general code knowledge. So for those that don't know Jerry's been in the Idaho code scene for decades now. He's in construction and has helped craft many of the IDAPA rules that are applied to the state's energy code, and knows hands-on what it means to do these things right, to do them well. And I'm excited to have him teach us about how to do a crawl space right today. So thanks for those online. You're on mute right now. There is a chat window. I'll try to monitor that. But you can also unmute yourselves and we can hear you in the room as well. So with that, Jerry, thank you. Over to you.
So yes, please feel free to ask questions. I'm here for you guys. And we don't want anybody to leave if they still have questions about it. Very much appreciate Damon and his efforts. I do have a pretty diverse background, been in construction most of my life, spent time with the legislature. I was the Energy and HVAC Program Manager for the state through the Division of Building Safety for a number of years. I've been doing trainings around the state since early 2000s. And I also do this work. So the stuff that I talk about, the stuff that I point out, it's not, I would never ask somebody to do something that I don't have personal experience or that I haven't done myself. Crawl space is an interesting topic because I'm in the middle of one right now. I've been in there for weeks. What started out with a, hands over your eyes, don't look, keep the flashlight on the narrowest beam, to getting it all cleared out and ready to make the next steps where it's now comfortable, clean, and mostly bug-free, so that we can move on to the next steps. And so I want to talk about crawl spaces because it's a big part of the house. And I do a lot of other trainings. I look forward to presenting additional materials as we go through the year. But everything starts with, first you have a roof, you need to get the water and stuff out of there, but really the foundation of the home is critical. And when we look at houses and how they're designed, how they're built, the house itself, the box, is not that problematic. New windows, new doors, just getting better and better. It's what's under it and what's above it that's created the problems. And so we can't talk about building an energy efficient house without talking about crawl spaces and attics. It's just part of it. So today we're going to talk about the differences between unconditioned and conditioned crawls, some of the benefits, potential downsides of conditioned crawls, the best climate, and some of the best practices. And it's interesting because you'll see I use conditioned crawl space term a lot, but if you were to do a search in the code books, if you search conditioned crawl spaces, you're not going to come up with anything. That's not a term that they use. We have crawl spaces, we have conditioned spaces, but in the code, there's nothing specific to conditioned crawl spaces. And so it's a generic term that we use in the industry. What we're really talking about is a sealed, mechanically ventilated crawl. The conditioning, I'll show you how that happens or why that happens. I did go to a lot of effort last night, early this morning, to revise this. I had some new pictures and stuff, and for whatever reason, Microsoft wasn't liking me today, and it wouldn't let me save the changes and stuff. So I'm gonna go back and work on that some more. But so some of the stuff that I had really, really good pictures of, I'm gonna have to draw it out with my hands. So Traditionally, crawl spaces aren't anything new, whether it's a crawl space, root cellar, a basement, underneath a mobile home. There's a lot of different avenues for crawl spaces, and traditionally, it's just been an open type foundation with some vents in it. And the thinking is that you got holes all the way around it. The air comes in one and goes out the other. In theory, and in the windstorm, it works that way. You put pressure on one side, creates negative pressure on the other side. Air flows through. When the wind's not blowing through, they act like a draft on a chimney, and all of them come in. How do I know this? Set smoke bombs up outside of each of them and watch them come into the house, and they just flow into the house. And the reason is really simple. Houses, just because of the design, because of how they work, are negative. I've never tested a house that had equal or positive pressure unless all the windows were open. The houses, because of, heat rising, call it stack effect, they just tend to be negative. And as houses evolve, we're putting in more bathrooms, more fans, laundry rooms, big range hoods, dryers. We just keep adding to all these things that's pulling air out of the house. It hasn't come in somewhere, and the big holes in the floor are a good entry point for it. So keep that in mind when we're talking about it. The other part of it is that, when we talk about conditioned spaces, we're trying to, firmly isolate a space. And if it's 0 degrees outside and you have holes around the house and it's pulling, you're introducing all of that cold air under the house. What else is under there? Water lines. In old houses, all of the heating equipment is metal. Metal transmits heat 1,800 times faster than wood. And so everything late 1970s and older is going to be pretty much predominantly metal ductwork, uninsulated, and the floors are uninsulated. So holes in the wall, metal pipes, most of the plumbing is going to be copper or galvanized. We didn't switch to plastic until the mid 80s. And so we still see copper, even up into the mid 80s. And so there's a lot of stuff under there. And from an energy perspective, when we start looking at upgrading these houses, what do? First thing we want to do is keep that cold air from coming in and up through the house. And so, we look at the crawl space, and the way the code reads now, it says the floor above the crawl space must be insulated. It's a good approach, but the house that I'm working on right now, it has tongue and groove subfloor that goes directly over the foundation walls. There isn't even a rim joist. It literally goes right over the concrete foundation walls. Then it comes in every 4 foot, there's a pony wall that runs the entire length of the house on a beam. And that's what the tongue and groove goes over. So there is no floor joist. There's 4 foot openings between it. And so trying to insulate that is going to be problematic. Spray foaming it would be outrageously expensive and probably not something you're going to recover your monies from. Other houses have a mixture of, post and beam, non-traditional spacing. There's just a lot going on over there. Some of them have, I call them wing braces, but they've got the braces that go up between the floor joists that kind of prohibit you from getting stuff up in there. There's just a lot of stuff in there, but it's important to know that, outside of a few jurisdictions in the state, we didn't have building codes that address that. And so it's very common for houses built prior to the 80s to have nothing below the carpet. They're just wide open. And they didn't have anything to seal them with either. And so all the pipes, all the HVAC equipment. Tub drains are a huge thing. They're all just open. In fact, the house I'm on, because it had the tongue and groove, they couldn't just cut a section out because there wasn't anything to support the ends. And so they just left it out. And so you got a metal tub basically setting on those posts and beams with no floor. It's open to the crawl space. And when I was working on it, I started working on it. I said, do you guys use this tub? And it's like, no. I said, why not? So you can't keep it warm for even 5 minutes. If you want to take a hot bath, you have to leave the hot water running, and it runs out of hot water. And it's like, I could have taken, you can see why. And so there's a lot of that stuff going on. The other thing is a vapor retarder may be required, but it's only required on these open foundations if you want the exception, or if you're trying to meet the exception. And so, again, it's not uncommon to find houses that don't have any vapor barrier under them because there wasn't anybody inspecting it. This exception didn't exist at the time, and there wasn't anything that said you must do this. And so it's not uncommon to crawl under a house, no insulation, open foundation vents, no plastic, nothing, and everything just kind of hanging in the breeze. Now the code says ducts have to be sealed and have a minimum R6 in the crawl. Back then that requirement wasn't there. We didn't have, they didn't have flats when these houses were built. So we're kind of evolving to sealed crawls. And I would say in Boise, I don't know, depending on the region, I'd say we're somewhere between 70 and 90% sealed crawls now. And there's a bunch of reasons for it. One, it's simpler. Trying to place the foundation vents is kind of tough. We've also changed the way we structure the houses. So we're dropping the TJIs down inside of the foundation. And so you've got to, typically you only have about 8 inches of wall exposed outside. And that's where your foundation vent needs to be. But now you're in the truss joist, and that's where your insulation needs to be too. And so we have a few builders that just kind of fold the insulation up and stop it right there to let the foundation vent still work. But then they have to put a well around it. And we quit building rectangles. Back when most of these older homes were built, there were squares and rectangles and a few L-shaped houses. And now the floor plans have gotten really elaborate. And so there's some, I wouldn't say vagueness, but the code is written in a manner that says, they have to be in a certain area unless you do this. And if you do this, it has to provide cross flow. And then it's kind of like, well, what is it? What do you want? And so, do they have to be within 3 foot of the corners? Some people will say yes. Code doesn't really say that. It says unless they're installed in a manner that provides cross flow, but it's problematic getting into these corners on these houses and have bay windows, patios. Sometimes they'll have a patio out front between the garage and the front door. And so you have an area there that, nobody wants a well in there for a foundation vent. So they're just moving more towards sealed crawls. The other advantages with a sealed crawl is you're only insulating about 1/4 of as much space. So if you're insulating the foundation wall versus insulating the floor, it's a lot less area. By doing that, you warm the air up in that space. And if it's sealed properly and insulated properly, that space now becomes part of the conditioned space. So it changes the volume of your calculations for air changes per hour. You're adding that. So an example, you have 1,000 square foot house with 8 foot ceilings in it. So your interior volume is 8,000 cubic feet, but you got a 3-foot crawl and you go in and seal that crawl and insulate it. That space below there is now insulated. And so you're adding about 40% more area to the house. Now you have 11,000 feet and they don't tend to leak. And so you automatically get less air changes because you've increased the volume of the house. Because it's warmer down there, your heat ducts are warmer, your water pipes are warmer, your floors are warmer. There's a lot of advantages to it from an energy perspective. The modeling for various reasons doesn't always reflect it. And I think it's because they're the way they do the algorithms, it just doesn't pick it up as if you were to go in and manually enter that information as if there wasn't a crawl. So if you said, well, the floor is insulated and you add that 3,000 square feet, you get different numbers. So hopefully that's something that they work on and adjust for that. But I have a lot of experience with sealed crawls. To me, every major retrofit that I've been involved in a house, I highly recommend that they do that. And it's always been beneficial. So, and it just makes it a lot nicer space under there. Like I said, I had some pictures that I want to show you. But the other thing with the foundation vents is it provides an entryway for pests, bugs, things like that. It's like perfect habitat for them. And they get knocked out, and the cable guys bash them out and run all their cables through there. And people run dryer vents out through them, and so they just become these bug havens, around the vent area because it's moving air. It's consistently temperate. So, having a sealed crawl, properly sealed, you pretty much eliminate the pest and stuff coming into the house. So this is one way of looking at it. Whether this is a basement or just a crawl space, we're just moving the thermal boundary down. This is one example. This looks closer to a basement, but you could do the same thing by coming down this outside wall and bringing this space in here. And so if you came in here, down this wall, and then up this wall, and people say, well, nobody insulates the floor, and back to those learning objectives when we said what climates, are conducive to these crawls. Idaho is blessed with really warm ground temperature. And so if we have warm ground temperature and we can maintain that ambient temperature within 15 degrees of what our set points are, then we don't need to insulate this. And so I've been monitoring, I think, all of the houses I've worked on. The ground temperature after just doing the walls is consistently 57 or 58 degrees. It doesn't change much. It stays there year round. And so if your set point is 72, we're 14 degrees off set point. There's not enough temperature difference to warrant insulating that space unless you're trying to use it for unoccupied space. So we don't typically insulate that floor, especially in a crawl. You can, but we typically don't. Really, this is the difference is, we're just moving it from here over to here. There was a period of time, I'm going to say from the early 70s to probably up until the 80, where they were doing both. They weren't doing floor insulation, but they were doing vented crawls with a 1-inch styrofoam on it. And to this day, I have no idea what their reasoning was. It's kind of like insulating your walls and leaving the windows open at wintertime. It just doesn't, I don't know why they do it. But it does create a problem because if you are trying to spray foam that styrofoam has to come out. Styrofoam and spray foam don't play well. And so if you have styrofoam and it's still attached, which is another kind of sore subject, you're better off to try to attach bats over it or add something to it versus, you know, trying to spray foam. The problem with the styrofoam is that if it's not attached, it's like holding a blanket out away from you and trying to keep warm. You know, if there's air movement behind that insulation, then the insulation doesn't really do much. And when it's just styrofoam, it's not a lot of insulation. So I don't know if it helps or not, but you know, leaving that, sealing that and leaving that as your only insulation is probably not ideal. And then the other, I think it's another note, but the other thing on the insulation, in the code, you'll see the tables in there. It says that the insulation has to go from the subfloor down to the footing and then extend horizontally or vertically for another 24 inches. I've never seen that. If somebody's doing it, you know, congratulations, but I've never seen it. Usually we just come straight down and call it good. The reasoning, I understand the reasoning, and it's to provide a longer pathway. You know, if we can bring the, you know, if this is the cold and we bring this out further, then it's farther for the heat to go around it. You know, dirt has, I think one for the dirt is R2. It's not much from an insulation value, but just know that we don't see anybody doing that. They're just insulating the wall and calling it good. There's some debate about whether it keeps the crawl spaces dry. And again, I would come back to, if you have moisture, you need to deal with the moisture. You know, you need to deal with it specifically. The code really isn't designed to cover across the board. We have certain areas of Boise that are subject to high water levels. That area out around Micron is notorious for having high water levels. There are some areas along, obviously down by the river, down around Eagle Island. There's areas down there where we have high water tables. And so we're talking about something different than just dealing with, you know, condensation. And so a closer look at this picture, that all of this black is actually mold growing on the wood. So this is a very humid crawl space. And I would say that whatever they're doing, it's not working because something is cold. You know, you have to have a cold surface for the water to condense on. You know, mold takes three things. It takes warm temperatures, some level of moisture, and something to grow on. And so if these are cold to the point to where they're condensing, there's something going on. I've never seen this. Eric put some of this stuff in here. Eric Macklin. So this is problems that I would say are not too typical, but definitely kind of goes back to, you know, would a sealed crawl perform better? You know, but if you've got bulk moisture under there, we need to deal with that kind of as a separate issue.
So Jerry, how would you? So
if you had bulk moisture under there, you're talking about some type of a perimeter drain inside the foundation. It's pretty typical for houses to put them around the outside of the footings to drain the water away. But if you live in an area that has high water tables, you would want to do it on the interior and provide a gravel bed for that to lay in with the sump pump and get that bulk water out of there. Provide a way for it to drain. And again, I don't, you know, I would have to look at the quantities. I did some work out in Fairfield. They have standing water And there was also some areas in Sun Valley where their water was actually up above their ground level. You could open the hatch and see water standing in there. And so those areas, they tend to put a gravel bed over the whole thing because they don't want the water puddling. They seem to be okay with it being wet, but they don't want throwing mosquitoes, I guess. We do have some areas where that is problematic. And in those areas, I think you would have to do more than just put in a sealed crawl. You're going to have to address that. Provide some type of mitigation for that. But again, it's not common. The other thing that has changed is this floor insulation. For years, it said it had to be in contact with the floor, which is a good thinking, but the reality is it's hard to hold it up in there. And so, having that dead airspace doesn't hurt anything. And so now they allow you to be, flush with the bottom of it, which is much easier to secure up in there. So again, I like the concept of the sealed crawl. I've been an advocate for that type of an approach, but it does. There are some other things that come into play. This is one of those things, that I left in there because when we first started doing sealed crawls, there was a lot of debate about was there any benefit, because it wasn't showing up in the modeling. We'd model the houses with or without it. You couldn't really see this big advantage to it. And they said, well, it keeps the ducts warmer. Well, it keeps the whole house warmer. And if you can stabilize the temperature under the floors are warmer, the pipes are warmer, everything's warmer. But if you are over insulating the ducts, then you're preventing that heat from getting out into that space. And so are you diminishing some of the other values in it? So my feeling is that you're not going to save it in the duct insulation. That's not where the savings actually comes from the air sealing of the house. And to give you an example, my first house, I only had two. My first house was built in 1973. I did a spray foam sealed crawl and hit the tops of the walls that I could get to in the attic, and the house went from 7.8 air changes to 1.78 in a period of 4 hours. And the energy was dramatic. It cut the bill by 60%. It's huge. And I don't even know how, it's hard to do that. But that was what we did on that house, and it was magic. And so, the benefit was instant. We could tell as soon as they were done that something was different in the house. And then the bill reflected it, right away. So I think that it's a combination of a lot of things, but there are some energy benefits to it. It kind of depends on what's going on when you start. In an older house, that doesn't have conventional spacing and stuff for putting in insulation, I think that's your best cost option, is to convert it. So if we do this, I'm going to read what the black bar is. Thank you. We need to have a vapor barrier under there, and that can be 6 to 12 mil. The code says that if you're doing a vapor barrier, that all the seams have to be overlapped by 6 inches, taped and sealed. This can be tape or some type of elastomeric or Volcom, but you can even heat weld the stuff. But they do have to be sealed, and it has to extend up the foundation wall at least 6 inches. I don't know how many of you guys do this kind of work, but if you've ever tried sticking Visqueen to a dirty concrete wall, Yeah, it doesn't, it just doesn't stick. I mean, it's wet, it's dirty. It doesn't stick. I like Volcom, which is like a gutter sealer that never cures. It seems to stick pretty aggressively. And they actually make a two-sided tape that you can put on there that the plastic sticks into pretty good. But the best way to do it is just to run it up and over the top of the foundation wall. We don't see a lot of people doing foam these days. Like I said, they used to do a lot of styrofoam, but there was no plastic behind it. They just ran the plastic, kind of cut it around the edges, and so they never made the seal. And then the styrofoam wasn't really secured. It had like a little metal cleat at the bottom of the footing, and they'd jam it on to that, and they'd drive a nail into the concrete while it was still green, and if it held, it held, and if it didn't, it fell out. So we don't see this approach. If you're doing this, it would have to be done before you put the floor in, because otherwise you're snaking all this through the crawl hole, and it's just wouldn't work. I have, like I said, I have better pictures. And then this is a version of, this could even be like the EDPM roofing material where they heat weld the joints together. It would be very expensive, but when you're doing this, you have to cover everything. This is just a hole in it, so you still got moisture, and I'll talk a little bit about radon, not too much, but somebody pointed it out that that's not sealed, and it's like, okay, how are you gonna seal that? And you'd have to literally get up and wrap it all the way to the post and cut it around. My first house had piers, like round concrete piers with posts and then beams. And you'd spend days in there trying to seal around all of those. And so, it can become really difficult trying to do this right. Imagine this house if they didn't put a vapor barrier in it before they set all of the pony walls. So, and this, looking at an old piered house would not be much different. So we try to get them to, even if they're this is sealed crawls, you can see there's no foundation vents. But even if this was on foundation vents, we want them to get that vapor barrier in there while you can still see it and get to it. It'll take them an hour and a half to put it in now versus, a couple of days later.
So Gary, the previous slide.
Yes.
The solution to this problem then is to lay the vapor barrier down before everything else is that, or is the cutting out and wrapping it kind of the only way forward?
If it's already in, you got to wrap around it, and it's just time consuming. It's not undoable. It doesn't look pretty, if you're going to do it in a reasonable time frame. Basically take a big square, cut a slice up through it, fold it around, tape everything. But it can be done. It's just the quantity of these could be taxing. So this one, the best thing to do is just lay everything over the top. This is pretty common now. This, we don't see the continuous ones anymore. So this is kind of how they do it now. And then these will get pony walls that come up, and then TJIs, cover the whole length. So you do get a standard floor joist in there for insulation purposes. This particular builder is doing insulated foundation walls, as is most of them now. So step 2, this is what I talked about, insulate from the bottom edge of the subfloor down to finished grade. This is grade in the crawl. And then it's supposed to go an additional 24 inches. So I haven't seen anybody doing this. And they don't, well, I'm just reflecting what the code says. I gotta be careful then. I don't get my opinion in there too deep. I like spray foam, but it is very expensive. And so there's, the best way to do it would be spray foam. It's fastest. It's permanent. It's closed cell. There's no doubt to its sealing capabilities. It's just a cost item. And cost-wise, it can be 3 to 5 times more than the bad insulation. But again, if you're taking your floor spare, if you're doing R30 on the floor versus an R15 continuous on the foundation, this is actually a pretty good trade-off. And then you get the benefits of the sealed crawl. So it depends on how if you're comparing apples to apples. So here are the current codes. This is 2018. Like I said, we don't see much rigid anymore. It's either going to be, fiberglass, could be mineral wool, or spray foam. The values are both the same. They're both 15 and 19. The first number is continuous. And so if you're doing a foundation wall without structure in there, it would be continuous. If there's studs and stuff in there, or you have raised portions with studs, it would have to be R19 in those locations. So the spray foam runs between 7.2 and 7.5 per inch. And so 2 inches should meet the R15. But the spray foam guys don't like to do, they can only put on 2 inches max at a time. And so most of them want to put 3 inches. They want to take it to R21 and try to get them to do that R15. It's like, well, we don't do it that way. Yeah. They want to put it on a little bit more to make sure that they've hit that. And of course they get paid by quantity, by square footage. But I have to keep reminding them this R15 is, if there's a reason why we have that number on there, it's because it's 2 inches of spray foam. So, this is how you do it. If like I said, modern houses, we drop these down inside the foundation wall. So we don't have these rim joists, but in older houses, you've got that rim joist that needs to be detailed. And before they stuff this in there, they should be, air sealing those joints in there. If they don't, they're really missing a big opportunity because these things leak really bad. Older houses, you can see daylight out through there, and that's kind of where all the critters are coming through. So it really helps to spend some time in there. We don't see a lot of gravel on the floor of the crawl unless you get into these high areas. This is pretty common over in Sun Valley area to see the gravel under there. It's not fun to work on. It's tough on the knees, but we see it more over there in the high water areas than we do here. I've never seen this here in the valley. And then they just drape it down to the ground. And so, if your sides are in contact, you could call it continuous. It kind of depends on the quality of the install. My fear is always that this product is not super stable, and depending on how it's secured in there, I'm one of those guys that's probably going to look at it. I don't know now, but what's it going to look like 20, 30 years from now? The first time this starts getting wet and the moisture starts migrating and pulling on this, is it still going to be there? That's my concern. How are you securing that? Because if it's just sitting there, it's going to fall out and it'll be on the floor.
Well, and Jerry, how do you get, in that instance, if that roll of insulation goes straight down, there's a gap where the joist would be.
Yeah.
How do you fill that in?
Well, that's what I say. You couldn't count it as continuous.
And get a cavity.
But if it's not touching, it's kind of back to this styrofoam with the holes in it.
Right.
Are you really getting there? I don't see too many bare bat like this. Most of it has the barrier on it. And then they, instead of having the barrier, they said barriers to warm side, and which changes throughout the year. but they'll staple the bats together with the paper or the vinyl. So the best product for this is vinyl. And, or they'll turn it the other direction, run it wide. And then you've got a lot, you've got that vinyl to staple up against. But I don't see too much unfazed stuff. I'm gonna have to presume that there are vapor barriers on the outside of that wall. Because there's nothing on the inside. But I do like the working space.
Yeah.
What I'm in now, it's not that deep. It's 24 inches to the bottom of the joist. And 18 is legal, so they get tighter. I've been in some that you have to decide, are you going in on your stomach or on your back? Because there's no rolling once you get in there, so. Again, this is just some different ways to secure it. We see a lot of these big plastic head Hiltis, and you want to watch your pressure on those, because if you sink them in too hard, the heads pop off of them. And so I see a lot of those plastic crowns laying in the crawl. So want to use a longer nail and not put a ton of pressure on them. They'll hold better. This is my house, my old house. Actually, it's not. It looks like there's cinder block. Anyway, this is kind of what I did on my old house, was this technique, and I said it worked amazing. I had the joists up above. The problem with that house is they used 2x8s and they overlapped. The house was only 24 inches wide. And so it had 3 sections that were overlapped, which made all of these goofy spaces for putting the insulation in there. So you couldn't get the bat in there properly. And so I looked at it, I thought, well, I'll have to cut it the other direction, and notch it and make it work for all these spaces. And then I started thinking about how many weeks I was going to spend down there playing with the bugs. And then I called the spray foam guy, and I said, how long does it take you guys to do this? And he said, oh, about 3 hours. Okay, let's do that.
Yeah.
I said, what about all the bugs and stuff? He goes, oh, so they make good filler. I said, do I need to clean it in that? He goes, no, none of it. And no matter how disgusting that would look, there's enough pressure when they spray it. It really makes it nice. When I did it, I was really proud of it, because I'd been monitoring my utility data for a couple of years, and I had all of the data and stuff to kind of prove my point. And so I did a presentation at one of the Idaho conferences, and then a little group huddled up afterwards, like, you can't do that. It's like, what? It's like, you can't do that. Like, why? It's got to be fire rated. None of that stuff's fire rated. So you're gonna have to go spray this into, help me with the word here,
Intimate.
intumescent. It's a fire, it's like gunite, right? Some type of a fireproofing that costs more than the spray foam. It's pink, like Pepto-Bismol pink, so you know exactly what it is. It's like, you're gonna have to spray all of that. So I called the guys, and it's like, no, we're good. Says, we've been working through the ICC approval process, and you got some numbers for it? He goes, oh yeah, we'll send them right over. So they had 2 products that had already been approved. And so it was all good. But yeah, it's a little panic.
That's
a little bit.
spray foam. I know a lot of times we require certifications when that spray foam comes in contact with like plastic pipe. It will. So there's some exceptions. The electricians don't want it anywhere around their wire, because it doesn't let the Romex swell and pass heat. And yeah, I've heard a lot of, it was a hot topic for a while. I think pretty much everybody's kind of okay with it. We haven't had any major issues with it. I do have the ICC evaluation numbers for multiples of this product if anybody needs it. But
yeah, I have some current cut sheets. I have older ones, but I can't ever find the current ones. Or they
Yeah,
expire the same
mine
year?
are
You know, if they say that?
probably 6 or 7 years old.
Oh, okay,
But they're still current.
okay.
Tiger Foam is one of them.
I've had the Geico.
The other real popular one. But most all of them have went through the approval process because this is their market. This is what they want to use it for. It's this application. And then the code does provide some language for areas that are not being used as storage or occupied spaces and stuff. There's some exceptions in there to it. But yeah, there is some cautions about the plastic and the Romex. If you have, you know, depending on the house, like I said, we've kind of gotten away from rectangles and boxes. And so now we have foundations that kind of up and down, step up and down and multiple levels in the house. And so it's really common to run into these kinds of situations below the floor with these step down foundations and stuff. And this just really save you some time on it. I'm just going to say, please seal all of this stuff. It's down low. It's an easy access point for moisture and pest. And I want to make sure that we get these sealed. They say 90% of litigation is caused from moisture, something along those lines. So we just try to keep it out of the house, but this is an area that definitely could use more work. This is another area, you know, I talked about bringing the plastic up and over the foundation walls. But when they put the sill plate down, they need to fix this too. This is just a straight pathway. This is your green boards coming together in the corners. And this is such an easy fix. Because when they put the subfloor down, they got that huge glue gun. It's like, please fill the cracks. You're right there. It's in your hand, you know, you got to glue it all down. And you don't have to fill the entire thing. Just fill it on the outside, you know. And it's like, okay, yeah, I get it. Otherwise, you just have an open channel. And things like mice, you know, they don't need a huge hole to get through. If they can sense that there's air moving through there, they'll make that hole big enough to get back and forth. And I fix this stuff. It's part of what I do. And they'll just sit there and chew at it until they can get through there. So if we seal it, this is good for about a half of an air change. Just this one little step that takes, you know, minutes to take care of. So it's something worth watching on your stuff. And, you know, sometimes they're just highly visible and you can see it when you're doing your framing. You stick your finger up on there. It's like, you guys don't seal this. A couple of reminders, and they'll get it. This is another really good approach. I like this, except that really the problems are in the corners and they didn't take their origami classes. So they tend to miss the detail. They tend to miss the leaf part. And so I have to show them, you know, run the stuff a little long, kind of fold it up, you know, tuck it up in there. But this is another nice detail to keep that bulk moisture and stuff out of the joints and stuff. You can see how this is all in here. But in the same picture, you can see where it's pulled because they didn't leave enough slack. And so it's pulled down away from the concrete. And so they have to go back in and try and tape that area that's fell. Elastomeric, I don't have my product stuff with me, but latex is for painters. That's the only place you should see latex on the job is for the painter. It does not work for any type of air sealing for a variety of reasons. So please use elastomeric or some type of a Volcom or, you know, some kind of a product that doesn't shrink. Latex is designed to shrink. It's water-based. It's solid. It's not flexible. It's just not the right product for this application. Closed cell spray can be either the spray foam or the cans, works really well. And then be sure to, you know, seal your joints. They do require condition crawls are conditioned, and that means we have to provide air in there. And so we have a couple of options. This is probably what most people are doing. We don't see sidewall vents. Most of these go up and out the top, which is the right way to do it. With some type of a makeup grill, transfer grill inside the house. And I would say the majority of builders are doing it this way. You can introduce air under the house and put a transfer grill up into the house. This is a little more exact from a design perspective. The problem is when the guys are doing their air balancing, they usually have one guy doing it. And if you're going to do this, there needs to be some provision for him to shut this off under the house. Or it's going to mess up his balancing and its flow rates and stuff. And so that's really the only drawback to this. This is the kind of the two ways that it's being done. I like a combination of both. And so the houses I'm doing now, I introduced air under the house and I have an exhaust fan going out. And somebody says, well, you're just blowing in hot air at one end and sucking it out the other. It doesn't really work that way. If you're doing even basic calculations, there's enough time between that when that conditioned air comes out to where it gets to the exhaust that it gives up its conditioning, whether it's hot or cool. I do a ton of monitoring, way more than probably most people want to sit through. But I know that if we're blowing 100-degree air out and heating over here, we're not sucking 100-degree out over here. It's pulling ambient. It just doesn't have the ability to hold its heat all the way across the house. It gives it up. So the only time where this really would come into play is if you're running a heat pump in the really cold days, because your heat pump can't supply enough. This will override the capability of the heat pump. So I wouldn't recommend this in a heat pump application, but there's a couple ways to do it. I don't want to breathe what's under here, even though it's clean and dry and there's no bugs in it. I still don't know if that's the air I want in my house. And so I set the exhaust to run about 60% more than what I'm introducing. So if this is pulling 100, I'm going to put 40 in. I want to keep that crawl slightly negative so that it's actually pulling house air into exhaust it, along with a little bit of conditioned air to keep that space negative so it's not exchanging in the house. It just makes for good air quality.
And Jerry, this is separate from the radon mitigation, which would go under the
Yeah,
barrier, right?
I think I've got a couple of slides in here. I'm trying to watch my timing here. There are, obviously, if you're putting combustion appliances in the crawl, they need to be direct vented. We don't see too much of that here, but it's still pretty common down in the Twin Falls area. They still put a lot of stuff. Water heaters under the floor. Don't know why. If it is truly conditioned, the ducts are not required to be insulated. So this is a big cost savings on an older home that has all metal ductwork. It's a good way to take care of all those plumbing pipes and all the heating pipes without spending the time and money to insulate all of that. Is just to bring it all into conditioned space. And that's kind of why I lean that way. It makes a lot of sense to me, cost-wise, to just condition the space. And the hot water piping is going to be improved. We don't have good numbers on standby losses. There's just too many variables. How many people are living there? When are you taking showers? Do you have daughters? Is it seniors? Are they living? How many kids? How much laundry? There's too many variables to give you any kind of a number on how much energy is lost through the hot water pipes. Plastic, if you're drinking hot coffee out of a metal cup, you can't hardly hold on to it. Plastic one, you can hold on to it all day. It makes a difference what the piping material and stuff is. So But if it is metal piping and you're conditioning the space, it's going to have an effect on it. One thing on the fan, and this is what we get the biggest complaint about, is the noise. And so the guys that are using cheap fans, guaranteed the customers are going to complain. And all of the fans come with some type of mounting. And even the inline fans have brackets. I've seen guys hook them to the side of the furnace, and it's like, great, you just hooked it to the drum. Yeah. So please mount the pipe and not the fan. Use flex connectors on the fan. Leave a 1-inch air gap on each end of it, so it's floating in the flex connector. It pretty much eliminates the noise. And so it's something we're still trying to do through training. Make sure it's rated for continuous, and you can overdo it. We only need 1 CFM per 50 square foot. But this fan, a typical inline fan is 110, 130. So we tend to over exhaust the spaces. And this is going to come up in our next training on fireplaces, because we start talking about why fireplaces don't work in new houses. And this becomes all part of that calculation, that thing we need to do before we build it. Don't do this. When it snows, this is going to get covered up. If they grow lawn up against there, the mower is going to smash this shut. Kids think this is a great place to stick things, and the bugs like them too. So this is not what we suggest. Plus, you just kind of clogged half of your foundation vent. So if you're going to run exhaust, run it up. Transfer grills can go through the floor or through the wall. If you're going to do it in the wall, please put a block above that, because we don't know that there might be electrical wiring above that. Electricians don't want things in there. They don't want, code says you can't run wiring in a plenum. And so you need to block that off so that it's not continuing all the way up to the top plane. So throw a block in there and avoid that discussion. Do they need a backdraft damper? Not required. Some guys put them in because they don't want whatever's under there coming back up into the house. But if the fan's doing its thing, it would be open all the time. So they're not expensive, but I don't put them in there. It is something there. I think that pretty much covers it. Couple of things on radon. I want to get you guys out of here on time. So how many of you guys are familiar with radon, know anything about it? Maybe heard some things about it? Do you know what the action level is? Do you know what a picocurie per liter is? Okay. I have a class, a 2-hour class on radon resistant new construction. If you guys are interested, let Damon know. I can schedule it, or at least let him know when I'm going to be doing it. So radon is another thing that we deal with. We don't have a lot of issue. It seems to get less as you move over towards Caldwell, but we do have some pockets up here in the foothills and a couple of places in town where we have high elevated levels, not dangerously high, but above the action level. All the stuff that we were talking about today, it comes up. Well, if I seal my crawl, is it going to make the radon more? It's like, well, if you're ventilating your crawl, wouldn't that make it less? And so just, without getting into a huge, debate or a lot of data, the houses that I've done sealed crawls on, I've measured before and after, and it can reduce radon levels by 50%, but it depends on where you start. If you're at 4, it can get it down into the 2s, which takes it below the action level. If you were at 10, 5 is still going to be above the action level. So it depends on where you start. If you have a radon problem, elevated levels, I wouldn't count on a sealed crawl being the solution. But you've put everything in there, right? You've got your fan, everything is in place. You could drop that down below the vapor barrier then now that is your radon mitigation system. There's a couple of pieces you need to add on it. And runs a supplier in there for your ventilation purposes. So converting a sealed crawl to a radon mitigation system is a couple hours of work and probably a couple $100 or less. So it's a good precaution. And if the other thing is to just install the passive while you're doing the fan, you know, you got a 4-inch pipe run up through there, run another one up through there and hook it down below the vapor barrier. And there's your passive radon system at the same time. If you need to put a fan on it later, it's right there. So big thing is do this, get this sealed like it's supposed to be. Prevent that from coming up through there. And you know, it can make a difference. And if you do have to put a mitigation system in there, this is the most critical piece, is this vapor barrier, and the most expensive piece of it. So if they have to come in and redo this, it's going to add $1 per square foot just to do the vapor barrier. So it's very expensive to go back and redo it. So trying to get that one right. The other thing that happens, and this is kind of last slide, is the radon varies in the wintertime. This ground around the house gets saturated and frozen and stuff. And so it kind of forces more into it because it can't get out through the frozen ground. So we typically do our radon testing in the winter time versus the summer, which brings us full circle back to the foundation vents. They'll tell you close those vents in the winter time so you don't freeze your pipes up. But then you're doing this by closing it. You're closing it at the worst time for radon. So it's something to consider. And there's my contact information. Thank you guys for questions and your time. Yes, sir.
I want to ask you a question about the sound. You talked a little bit about the sound proofing for the seal close space, right?
Mhm.
We had builders kind of complain about it, saying that, well, also because we've been doing a 2-inch concrete pad as well, and the close space. But they complain that it creates and not having the bad insulation on the floor in between the joists, it makes kind of an echo sound throughout the house.
Yes.
Have you noticed this? Has this happened?
Yes.
Okay, so a lot of them suggest to still do the bad insulation.
It's for, especially for houses that have predominantly hardwood, which is no carpet. The house that I live in now is almost all hardwood, and I would consider insulating parts of it because of that.
So you hear people walking on this end of the
Yeah.
house.
But you don't need R30.
Yeah.
An R15 bat right up against the floor would be adequate. So I can insulate it for sound, and I don't have to put the level of it. I have to put R30 into that.
I guess another suggestion that we had, or what another builder's trying is adding kind of honey walls with insulation. I don't know. Have you seen that? Have you seen anybody do that?
It's for sound, right?
Yeah.
And these are custom homes.
Yeah.
And pretty much high dollar homes. I understand the reason. I'm one of those guys, I insulate all my interior walls around all the bathrooms, the laundry room, all of that got insulated with a mineral wool for noise control. Yeah.
Another question I had was spray foam. I mean, we inside the seal envelope of the house. We avoid the spray foam because of the off gassing.
Yes.
Have you run into these? A lot of people. You mentioned that people are doing a lot of the spray foam now.
Yes, so the can foam, the quantity isn't there, but the spray foam, there is a 24-hour period where you're not supposed to be in the house. And anybody that's working around there, you're not supposed to be present when you're spraying. Especially inspectors, because they go out there, they don't know what's going on. I carry a respirator with me. If I even think that they're doing it, I'll put it on. But there is it does use a cyanide activator to make it work, an accelerant, and very bad for you.
Okay.
So the guys that are doing it, they have fresh air helmets. They're bringing fresh air in from outside.
So respirator really isn't adequate for application. But if you just had to go in the house and look at something, it might be, it would be okay. I'm not recommending anybody does that. I tell them 24 hours, stay away. And on older houses, I have them take their pets somewhere else. I just don't take them day one. So, yeah, I'm aware of the safety part. There is some new product in development. There are some green products that use a cellulose, a plant cellulose as the primary insulator and using CO2 like wow as the activate. And it's been out for a couple of years. And really, I think that's the direction that industry wants to go, is more to that direction, because there's nothing hazardous in it. And we don't have the potential, I mean, it can be misapplied. It is temperature sensitive. I've seen spraying in eastern Idaho when it's below freezing, and it's like, you guys not read the label. It has to be 45 or ideally about 55 to get it to do its thing. So there are some precautions there, and you can get it wrong. And if you go on YouTube, there's horror stories about people doing it wrong. Mostly they're not allowing it to gas out before they put multiple layers. They're trying to put too much on at one time, 2 inches max per spray. If they're doing a 3-inch spray all at once, the inside can't cure. The outside will cure and lock that gas inside the product. It smells like fish. And that smell will never go away. It's trapped. But as far as the heat buildup and stuff like that, I haven't seen any of that. I was concerned about the fire part of it. So when they were spraying mine, I had them spray some 2x4s, and I went out there and threw them on the barbecue and just let them sit there and cook. And it never got to the 2x4. So it don't matter how long the fire's on, it will not burn through it. The char just glows and gains the heat and will pass it to the 2x4.
Here, you've got a question from
Yes.
online. It's from Brendan. 3 to 4 years ago, most builders were moving to conditioned crawl. Most are now moving back to vented crawl. This is because they can control mold issues during wet construction before it's dried in.
Yes.
The subs don't keep the fan running. Mold mediation now costs $5K. Bill says it's not worth the headache. Do you have solutions for this?
Yes. I'm surprised that it has reoccurred. I did a lot of training on this years ago. One of the things that we run into is in the wintertime, people want to do all of their foundation pours before it gets cold, because at some point you can't get concrete delivered. And so those crawls just become a big swimming pool all winter long. My suggestion is to get that vapor barrier in there and get it sealed as quickly as possible. And just deal with the flow of moisture on top of the plastic with either shop vac or a pump if it's needed at that level. But get the vapor barrier in there before you ever start putting any wood. And then the fans have to be running. Something, we're not talking about a box fan. It needs to be something that can move some serious air. The builders that I work with, they will actually chop in another crawl space hole, so they'll blow air in one with a big fan and pull it out of the other. And the guys that are doing that and getting the vapor barrier in early, getting it sealed, and running the fans are not having problems, and they're still doing it consistently. The other problem that comes up is with the subs tearing holes in the vapor barrier. And if you crawl in one of their crawl spaces, there's a sign right there at the entry that says any damage that occurs is the responsibility of subcontractors, and their job supers kind of keep an eye on that barrier. They leave tape there, So that if you do tear a hole in it, you could fix it while you're there. And then as the house gets closer to inspection, they have one of their guys go in and do a final cleanup and wipe down and check for tears and leaks. So yes, thanks for bringing that up. I need to put that in the presentation, because if you don't take some precautions there, you can introduce mold into it. Does that answer your question, most of it? So yes, I need to have that in my presentation. Thank you. Thanks, everybody. 2 weeks from today, I'm doing a segment on how to make fireplaces behave in tight houses. And so it's tricky. If we overdo the air sealing in there and then try to run fireplaces, it can not work so good. So I did a ton of work on that. I've done several houses where I went in and worked directly with both the fireplace guy and the HVAC guy. We can get them to work, but it's really helpful to know as we're designing a house, what you're doing so that we can do make some other adjustments.
Have you ever done a fireplace on a passive house certified home?
To be honest with you, I don't think you could do it. The specification on the air seal is 0.25, and I just don't think you can get there. There are ways to heat with wood, but an open fireplace would never work. I'm not sure if you're familiar with Russian stoves or masonry stoves that don't have a physical connection in the house. The heat goes in the house, but the stove is all external. So there are ways to make that happen, and I'll talk about that as part of the presentation. And me personally, I would definitely take that route. It's almost pretty deep.
Thank you.
Jerry, couple questions. With the condition crawl space and you're doing that transfer, is there any concern with odors coming back out of the crawl space?
I've never had anything in the crawl. The off-gassing from the spray foam. I hooked the fans up so that they were coming out of the master bedroom, the primary bedroom, and I left those ventilation fans going for 3 years. And then after the
Okay, so, so the backdraft damper, you say it's not really needed.
if everything is working, it's going to be in the open position all the time. The only time it would not be working is if the fan shut off. And usually the fan starts, the bearings go out. So you can kind of know.
So you recommend running that fan 20
It has to run, yeah, it has to run.
all the time? Okay. And then as far as those transfers, what do you try to do? Get one in one corner of the crawl space and
Well, we try to get the exhaust fan into the corner, and we want to pull from as big a space as we can.
Yeah.
In the smoke testing and stuff, it's surprising you don't really have dead air, because there's other things where there's temperature drive, there's other things that are moving the air. But yeah, you want to try to get your transfer door as far away as possible. And that's why sometimes it's better if you got a center of the house location. It would almost make sense to direct some air from the heating system just to move it.
So it's not real critical to get all corner points.
And I've got years of experience with doing the air issue.
In Jackson, we do a lot of energy recovery. And we've kind of switched from the transfer to introducing supplier off that energy recovery. Do you think that's a good route to go instead of the transfer?
So can you explain that again? What is it you guys are doing?
Energy recovery unit for ventilation of the house. We'll put whatever it is, 40 CFM, we'll put into the crawl and exhaust off that